So we've heard about the vision for UK AI. We've heard a little about the vision OpenAI has for doing this sort of radically innovative science. And we've heard about responsible AI's vision and some of the other important factors at large in society. For our next keynote, we're going to hear about something that I think all of us interact with every day and actually has a large impact in a small way on all of our lives. And that's the recommendation system that Spotify uses, and more broadly, the research that Spotify does to cater to our taste, to learn about us, and to provide us music to our lives. And we're very fortunate to have Mounia Lalmas, who is a Senior Director of Research at Spotify, come today and come and give us what I think is the first application that we can all relate to, that we all use every day. So thank you very much for coming. We're looking forward to the talk, and take it away.
Okay. Okay, thank you very much. I'm using this directly. Can you hear me well, yes? Okay, so yeah, I'm based at Spotify in London, and I will be talking about the use of AI, and I have a slightly more broad definition of AI. The focus will be on Spotify and on personalization, but in the context of a recommender and search system. It's going to be a little bit more researchy, but research that was shipped. And so on. So it's based on something that some of you may be already using, and it's also based on publication and so on. It is the collective work of many people at Spotify. So a bit of the outline, I will set up a bit the context. I think you might find quite interesting some of the basic things that upon which you're built on. I will focus on two use cases. The vertical cold start and the catalog discovery. I've chosen them because they capture something like a beautiful sweet spot of how we've been using technology to develop algorithms, but also following how the technology itself evolves and so on. It also showcases innovation, as I said, to impact into the product, and it also be innovation in a context that it has been presented at a top-tier forum in academia. And depending how it goes, I will explain a little bit what I think is next, but again, with the focus on personalization. Okay, so setting the context. Who has heard of Spotify? Nice. Who is using Spotify? Oh, wow. Okay. I tend to speak to researcher, younger people. I'm not saying that you're not young, but I was expecting more. Okay. Lovely. Okay, thank you. Okay, so first I'm going to start with some numbers. Those are numbers that we communicate on a quarterly basis. And the reason I show them is to try to really show you the scale of what we're trying to do. So we have more than 600 million active users. We have playlists, we have tracks, we have audiobooks, we have podcasts, and so on. So if you think of Spotify, it's not just music, it's really more about the audio. It's really the audio space and so on. And really to remember is like we need to do something with all those big numbers, and scale is very important. This is why the research we're doing at Spotify always have to take into account the scale. The work we're doing is based on around everything that has to do with personalization. So you have listener on one side, and what they want to do, they may want to be entertained, they want maybe to go running, and so on. So there's things they want. And then we have creators on the other side. They make things. For example, they can make their playlist, they can make a podcast, and so on. So personalization, our definition of personalization is really to connect what listener wants with the thing that creator make. And this is what we're trying to work and like every day. So personalization is also across surfaces. So you have the home, is when you start, for example, is where really what is called the core recommendation is happening. There's also search. you have a need, you want to do something, you want to discover something new, you use search. And then what we call set is within a session, within the playlist, and so on. So personalization is everywhere, but is also across the surfaces, which often need to be treated differently. The algorithm behind them are often very different. And it's also across verticals. We have, as I say, there's music, that podcast, that audiobook. Even in the context of music, we have various granularity. There's the track, there's the playlist, there's the album, and so on. So we have to take into account, and remember those big numbers, that's lots of content. So how do we personalize our recommendation and so on, so we can make as good job as possible, taking into account this, the fact that we have so many verticals with various level of granularity. So Spotify started around 2008, started with music, and it was like, okay, how can we do the recommendation? I was not in 2008, I joined in 2017, so I have nothing to do with that, but I still think it's super neat. And a lot of the work we're doing is based on this. So it was like, they were really trying to, okay, how can we do the recommendation and so on? And what came quite strong is that listeners were organizing the data themselves. They were putting tracks into playlists. And we have 4 billion playlists, and what was seen is often 2 tracks were put into playlists. So it means that there is a connection between those 2 tracks. It's a little bit this notion of collaborating filtering and so on. Co-occurring tracks mean there is a relationship between them. 4 billion of playlists, I mean, there's a lot of information to make sure it's not just pure coincidence and so on. So the foundation of a lot of the work that helped to do the recommendation and search is based on this. So we have what is called a massive embedding space. Some of you may have heard about word2vec. So in that case, the word is a track and the sentence is a playlist. So everything is in this embedding space. So each track, so now if you want to represent a user, you take the track that the user has listened to, so you can represent like an aggregation of those embeddings to maybe build a user profile. An artist is going to be represented in the same way. A genre is going to be represented in the same way, and so on. Again, this is not specific to Spotify. This notion of embedding space is at the core of many recommender and search systems. Also, for people to be aware, we talk about algorithm, we talk about personalization, and so on. Personalization should be viewed as an assembly layer. There's a huge amount of information, and the first stage is like reduce this information to what we call candidate generation. For example, using user profile, let's just reduce things to make sure that we're only the starting point is something that may be of interest to the user. We do this at vertical level, like podcast, audiobook, and so on. And then there is the next step, which is the relevance ranking. It's like, how do we organize, for example, the homepage, taking into account those verticals. And then there is a business logic. For example, there's a new vertical being launched, so maybe we want to push that vertical a little bit higher, and so on. So this is the third step, and so on. So it's always very important to understand this is like really an assembly. It's not just the one thing and only one thing. So going back a little bit to the 2 use cases, I will talk about kind of the technology that we have been used to handle the vertical call start, and then the second one on driving catalog discovery. And this is really mostly helping the candidate generation phase of this assembly layer. Okay. Okay, so solving the vertical call start, this is based on 2 papers that have been published, including one that was presented this year. So, online platforms frequently add new content verticals. Spotify started with music. In 2019, we went into podcasts, and last year into audiobook. And our question is, how do we develop representation that allow to do effective recommendation during the cold start phase? Why we need to do this well is when you introduce something new to a user, you need to do a good job, because often the first impression counts. So if it's not a good job, people will just, I didn't like this, and so on. So it's very, very important to always, any kind of novelty, to do as best as you can. And the cold start problem is not a new problem. So we started with podcast. Here you put podcast on the platform, you have a little bit of data, but not enough to do proper recommendation and so on. But we had a lot of information about music, what kind of music people liked and so on. So there's this area that is related to domain adaptation, which we decide to use. So we decide, okay, what is it that maybe in the taste of the user with respect to the music can be used to do podcast recommendation. We decided not to make a particular choice in terms of could it be this, could it be that, and so on. So we just took everything that we knew from user taste. Those music embedding, this embedding space, we use it. We have the genre information, what kind of genre a user is mostly associated with, and also the top artist. And then, so this is going back a little bit slightly technical. So then we have what we call sparse feature, where you have just a little bit of information related to some of the feature. And anything that is more like an embedding is what we refer to dense feature. And then what we use is extreme multi-class classification. So we have like a neural network. A lot of the work we have done really was starting with deep learning, and now we're moving slowly into more generative AI, and I will give an example later on. So we have this deep learning approach where what we try to do, we have user taste of information, and we try to predict whether a user is going to follow a podcast or not, and so on. And we built a user representation that optimizes for that task, and so on. So this was, there's much more to it than this. There's a lot of, how to find your negative sample, positive sample, and this kind of thing. But it just shows that taking information from one side of what you know from the user, and this is like the domain adaptation transfer learning, you can really get reasonably quite good information about another domain in terms of user taste and so on. So when we launched this, there was an increase in 15% of podcast stream rate, and importantly, a big jump in users starting to listen to podcasts. And we looked at what is the important factor that is a good prediction, and so on. And what we find a little bit more is, for example, some people were listening to Spanish-type music, and what was recommended to them was Spanish-spoken podcast, and so on. So this latent representation was doing a good job to try to map user taste across two different domains. This was in production in 2019, and it's still being used as part of the candidate generation for podcast recommendation. So that was the technology we used. Technology has evolved. There's the area of graph neural network that really made a big jump. It became much more scalable and so on. And this is what we decided to use when audiobook was launched in 2023. So here we have already now a lot of information about podcast consumption, and then, okay, we decide to use that to try again to do this kind of domain adaptation to some extent in terms of doing audiobook recommendation. We looked at the data. The kind of content user was listening into podcasts were much more related to audiobook and so on. So it was the hypothesis worked well. So here we use two types of kind of sources, co-listening, so a user listening to podcast and audiobook. There is audiobook on the platform. There's just not a huge amount of consumption data to do recommendation. But we also look at the content itself. What is the podcast and what is the audiobook about? So we built a graph neural network, and this is where we started to use a large language model embedding. We found in a lot of the work that they were pretty good at modeling the content, doing the content representation, in particular when there was not a lot of consumption data, and it was also helping less known content to get a better representation of it, so it could be a return. So what this graph is just saying is if a user listens to a podcast and an audiobook, there's a relationship between it, but each of the audiobook itself and the podcast, we represented its content. We took the title and the description, and using LLM, we use LLM embedding for the representation. So what you have now, if you have an audiobook, it has its own representation and is related to other things. So you use this kind of message patching that comes with a graph neural network to build a representation of a better representation of that audiobook that take into account surrounding things and so on. So this is another example how we evolve with the technology. LLM at that point was really getting good at content understanding, and the graph neural network is very good when you have like sparse data. It really is very good at capturing various information. And when the actual recommendation algorithm itself, we use the two-tower model. One of the issues with graph neural network is always scalability. There's 600 million users. We're not going to have 600 million nodes. It's just not going to work, and so on. So the two-tower model is about the representation of the user, and then we have the representation using the graph neural network and LLM of the audiobook, and we just built like a standard model into this. So again, this brought really good performance, and in particular, the good one is people getting interested in starting an audiobook and so on. And it's in production since July 2023. Who is reading audiobooks? Okay, good. Usually the younger generation, they don't, but okay. And we also now use that for podcast recommendation. Okay, so, let me see. Okay, so I'm just going to say one thing that we try to do because I wanted to explain one example of generative AI. Okay, so what is often happening in search, we have a massive catalog and users are maybe not the best to write the query that is going to find things that is in the catalog, and sometimes they're not even aware of what is in the catalog. And the usage of generative AI is for synthetic data generation. If you have enough example of what is a good query and what is a good answer for that query, taking into account like broad information needs and so on, you can actually train an LLM to generate queries that would be associated to like an entity and so on. And this is some of the work that we're doing is actually how do you expand? If you have a good understanding of what could be good result, what is a good query, and so on, you have still to find a way to build a data set, and then you use the data set to expand it further. So when you have new data, you can just, for example, generate what will be a good query to actually retrieve that entity and so on. It works beautifully. We were quite surprised. You still have to be quite smart about how you build the original data set and so on. Just as an example, you have a query, something has been clicked, you look at the title of what has been clicked. If it's very close to the query, you say, okay, this is like a narrow intent. If it's very far away, you will see this is a broad intent. So this is a way that you can do some weak labeling and so on. And this has been used, again, going back to audiobook, to make audiobook more discoverable. The title of the book sometimes has nothing to do with what the book is about, and so on. There's much more imagination and these kind of things. And so this is one of the usage of generative AI in our case, and so on. I just maybe wanted to finish about, which I think is interesting, a bit about our experience and I think where we're going next and so on. Again, the type of research we're doing at Spotify is to ship stuff and so on. But also following how the technology is evolving and so on. So the vertical cold start, it's the way we have handled it so far is like, this is music, this is podcast, this is audiobook, and so on. And we're looking into building general representation. And we heard earlier today, but the notion of multimodality is something that we believe is going to be super helpful. The other one is with respect to discovery. So I zoomed into discovery, but discovery is maybe one way to interact with Spotify or other kind of online system and so on. And we're moving slowly. There's maybe various ways to interact. Users are in very different intent and mood and so on. And this notion, also the algorithm and so on with generative AI is moving into more LLM. And this notion of what we're also thinking, and not just us, is agentic LLM. Everything is going to be an agent, powered with LLM to some extent and so on. And quite a big part of the word is the orchestration. You get something from the user, should you go there, should you go there, should you go there? If you go there, who are you going to talk to, and this kind of thing. I do think those are really exciting area, and they kind of really fit what we have in mind at Spotify. Thank you.
So we do have time for one question. Thank you very much for such a fascinating talk and really cool connection at the end there too to scientific discovery, which, one question over here.
Hi, thank you for the talk. Love the product. Use it like average of 4 hours according to my Spotify Wrapped.
Okay, no comment.
I wanted to ask, the collaborative filtering was really interesting, and one question that came up was that how do you deal with, I guess, new songs that someone would upload, which is like in none of the playlists, and how would you deal with like songs that are like in every playlist, like really popular? Wouldn't that kind of like widen the gap between them?
So from an engineering perspective, this is just the algorithm. This is the idea, but they get trained on a regular basis and so on. So we've been doing also some work about user representation. At some point, users are there in their journey, and then they start listening to something else, and they start to listening to something else, and so on. So there's a whole work, which is like another talk. It's like, how do you continually update things, and so on. From an engineering perspective also is stable vectors. You don't want that something come and everything crash. In a sense of crashing, that all the kind of near neighborness and things is not working. So you just add it slowly and so on. But that's more an engineering perspective than the algorithm. How often do you train and so on?
Thank you.
Yeah, thank you very much. And so I think everyone probably has some more questions for Mounia. I'm sure she'd be happy to answer a few. We have a break now, but we're running a little bit behind schedule. So could I ask everyone to just get up, stretch their legs, take a 5-minute break, and then we'll come back for the panel on AI and education. And then let's thank all the morning's panelists one more time. Thank you. Thank you.